All right, welcome. This is a quick video walking through the exponent properties needed for today's lesson. The first one we'll look at is negative exponents. The first thing you'll notice about negative exponents, if you want to make them positive, which you do need to do for directions, is to move them vertically in the fraction. So if I thought about this as a fraction over 1, if I take where it is in the fraction and move it vertically, it changes the exponent from negative to positive, as you'll see here. In this case right here, for this example, if I have 7x to the negative 4, you're going to notice that I have the x to the negative 4 part just to the negative power. So that'll move down, and then I'll just have my final answer of 7 over x to the 4th power. It's that simple. Now, next thing, you might also see a negative exponent show up in the denominator. Same idea. Again, if it shows up in the denominator like this, move it to the numerator, and it becomes positive also. So in this example, like you see here, this is my negative exponent. I'll move that up to the top. It'll join what's already up there and get multiplied with it. So the final answer to this one will be 15x to the 6th. So moving negative exponents vertically in the fraction is how you deal with those to get them to turn positive. You might also end up with some that have a whole entire fraction to a negative exponent. We can also flip the base. So in other words, if you see x over y, to make this turn positive, flip it over and have it as y over x, and then it becomes positive a. So if you saw a problem like this that has x squared over 3, and you have it to a negative 2 power, to change that to a positive 2 power, you flip the base. So I'll have that as 3 over x squared. And now it becomes a positive 2. And if I'm supposed to square this, the final result then would be I'm going to square the 3 and get 9, and square the x squared, and I'll get x to the 4th. We'll get more into that, why that is that kind of answer. Next, as I'm moving along here, multiplying expressions with the same base. If they have the same base, then you're supposed to add the exponents, essentially saying how many times you have that base being multiplied in the expression. So if I have x to the 3rd, which has 3x's multiplied here, times 5 more x's multiplied here, we have a total then of x to the 8th power, showing that you have 8 x's altogether multiplied in a row. Next, division gets a little trickier because division is about canceling, not adding the number of exponents. Because when you have a common factor of x in the numerator and the denominator, we can cross them out. So if I have 3 x's in the denominator and 10 in the top, I could then cross out both 3 in the bottom and 3 in the top, leaving you with just 7 left in the numerator. So I'd have it as x to the 7th power. The 5 had nothing to do with that, so it just stays put. And then also, what you're going to notice is that I could subtract simply to also talk about these cancelings that are happening. So if I just take 10 minus 3 and write your answer where the larger one used to be, that's where the 10 was in the numerator, that's why I then have my answer of 7. So again, all you're going to do is subtract the exponents, the larger exponent minus the smaller one. In some cases, you might have more in the denominator than the numerator, like you do here. So then we'll just subtract 15 minus 10, and then I'll have 5 left in the bottom, because 15 minus 10 is 5. If you ever cancel out the entire top, and 10 on the top and then 10 on the bottom to get the 5, there's always a coefficient of 1 that you didn't see there, so that 1 also shows up in your answer as well. So division, you're going to subtract. When you're multiplying, you're going to add the exponents. Keep those two separate. Next, if you see a power to a power is where you're going to then say how many do you have total. Well, if I have x to the 8th and then I have it b times, you're going to multiply those together and then get the answer like this. So if you have an expression like this that has 2, x to the 3rd, y to the 5th, and it's all being cubed, when you distribute this 3 in here, it is not 2 times 3, it's times the 2's exponent. And when you don't see the exponent, there's a 1 there. So that becomes 2 to the 3rd power. So I have 2 to the 3rd power, and then I'm going to have x to the 3 times 3, which then makes x to the 9th, and then I'll have y to the 15th. Now to get even more specific, that 2 to the 3rd power would then turn into 8, so you'd have 8. X to the 9th, y to the 15th. Power to a power, you multiply the exponents, keeping these things straight. All right, next, if you see 0 powers, if you see anything to a 0 power, it doesn't just cross out and poof go away, it turns into a 1. So if I see this whole entire expression to the power of 0, the answer is going to equal 1 because these all cross out and become a 1. In this kind of example though, if I have this 3 to the 0 power, just the x to the 0 power goes away to a 1, and 3 times 1 leaves you with a 3. So notice how that works. 0 powers turn into 1s, and like it did here. And if there's anything else left with it, it gets multiplied to the 1, like you saw there. We have 2 more things left. Next, if I have fraction exponents. If I ever see x to an a power over b, the a represents the power, and the denominator of that fraction exponent is the root. Okay? So as you can see that there's a root there, that's the same root we're talking about in the root symbol. Okay? So in this example here, I have x to the 3/5 power. That 5 is your root, so I'll put a 5 in the root spot, and that 3 is your power, like you see there. And that is your answer for what x to the 3/5 power is going to get written as when you write it as a radical. Next, you might also see things start out as a radical. If I have the square root of x to the ninth power, don't forget when we say square root, that's assuming that there's a 2 right here. The word square and the word number 2 go together in math. So if I'm going to write that as a power, don't forget it's always power, that's the 9, it's always power over root, so it's 9 over 2. And that x to the 9/2 power becomes your solution to that kind of expression. Lastly, if we have this 1-to-1 power, or 1-to-1 rule, if I have two things with the same exact base, that means the exponents have to also be equal. And once you get the bases the same, there'll be some questions in your homework that are a little more tricky than this, but this is the goal. We're trying to get the bases the same so we can then say the exponents are equal. And then in this case here, then x plus 2 equals 10. And if I finish solving the expression, equation, you'd say that x equals 8. And those are all the properties you need for today. Hopefully this video helps, and good luck.